Hello, welcome back. Today we're going to continue our work on factoring, and we're going to examine something called a difference of squares. So a difference of squares is when you have one squared term minus another squared term, difference being subtraction, squared being things that are multiplied to themselves. So let's go ahead and take a look at this. Okay, so here we are, a difference of squares. So there's our subtraction sign difference. And here's a first term, x squared is a square, x times itself. And then y squared is a squared term, y times itself. So now you'll notice that unlike our usual quadratic, we only have two terms here. So when you see one perfect square minus another perfect square, you know that this factors into x plus y times x minus y. So let's take a look at why this is true, how we know that this is the case, and what happened to our missing term, to our xy term. So let's go ahead and apply our FOIL, right? Firsts, outsides, insides, lasts. So the first two terms in the parentheses, x times x, gets us our x squared. The outside two terms in the parentheses, an x times minus y, gets us a minus xy. Our insides, the inside two terms in the parentheses, y times x, gets us yx, but I'm going to rewrite that as xy. Multiplication works in either direction. And then y times negative y gives us minus y squared. So take a look at the middle here. Minus xy plus xy. Those two terms cancel out and become 0, leaving us with x squared minus y squared, and that's where we started, x squared minus y squared. So the difference of squares, the thing missing its middle terms, turns into the square root of the first thing plus the square root of the second thing times the square root of the first thing minus the square root of the second thing. And that's what creates an outside and an inside that are the same but opposite signs, which cancel, and gets us back to x squared minus y squared. So let's take a look at how we apply our formula for difference of squares factoring to a couple of problems. So here's a first problem, x squared minus 16. X squared is a squared term, 16 is a squared term, minus is a difference. This is a difference of squares. And so I can set up my two parentheses. I know that one of them will have a plus. I know the other will have a minus. I know the first term in both will be the square root of my first term. I know the second term in both will be the square root of my second term. And just to show you again how this works, x times x is x squared, x times minus 4 is minus 4x, 4 times x is plus 4x, 4 times negative 4 is minus 16, 4x and minus 4x cancel, leaving me with x squared minus 16, difference of squares, and there's my factorization of it. Let's do it again. 4x squared minus 9y to the fourth. Okay, 4 is a square, x squared is a square, 9 is a square, y to the fourth is a square, that's y squared squared, and there's my difference. This is a difference of squares. Set up my two parentheses. One of them will have a plus, one of them will have a minus. My first term is the square root of my first term. The square root of 4, what times itself equals 4 is 2. And the square root of x squared, what times itself equals x squared, is x. So 2x is my first term. For my second term, what times itself equals 9? That's a 3. What times itself equals y to the 4th? That's a y squared. And so my factorization of 4x squared minus 9y to the 4th is 2x plus 3y squared times 2x minus 3y squared. One more time. All right, I switched things up a little bit here. My variable is sitting over here. Doesn't matter. 64 is something squared. X to the 4th is something squared minus, there's my difference, parentheses, one gets a plus, one gets a minus. Square root of 64 is 8. Square root of x to the 4th is x squared. And there I have it again, my difference of squares factored. Okay, so there you have it. That is the concept of difference of squares, when you apply it and how you apply it. So go ahead, keep practicing, and take a look for more videos in our factoring series. And as always, keep on mathing.